Okay, the second type of limit that we want to work with is a limit as x approaches infinity of some function. We say that a limit exists as x approaches either positive or negative infinity if the y value of the function gets closer and closer to a particular value and it doesn't grow without bound. So some examples of this, or some important notes. When a limit exists as x approaches infinity, we also say that the function has a horizontal asymptote there. So these two things are synonymous. The limit as x approaches infinity, assuming that it exists, and the horizontal asymptote. This is very important. So in the first example here, this is like the e to the negative x exponential function, and as x approaches infinity, the y values are getting closer and closer to 0, and they're not growing without bound. On the other hand, the limit as x approaches negative infinity does not exist because the function grows without bound there. So let me write some of that down. So in this particular example, the limit as x approaches infinity of f of x is 0. And we can also say that the function has a horizontal asymptote at 0 as x approaches infinity. Now, we also say that the limit as x approaches negative infinity of f of x does not exist because the y values don't get closer and closer to a particular value and stay there and not grow without bound. So because it grows without bound as we approach negative infinity, so that limit does not exist, and there is no horizontal asymptote as you approach negative infinity, as x approaches negative infinity. All right, the second example is that a function may never attain the value of the limit as x approaches infinity, but it might. So here's one example. So in this case, the function crosses the x-axis an infinite number of times on its way out to positive infinity. However, we would still say that the limit as x approaches positive infinity of f of x is still 0 here. Now I've used 0 in both of these two examples, but obviously the limit doesn't have to be 0. The limit could be something else. But this particular example, example number 2, just goes to show that the function can cross over the horizontal asymptote. It's not like a vertical asymptote that can never cross over. It can cross over and the limit still exists there. So the limit as x approaches infinity of f of x equals 0, we would also say that this function has a horizontal asymptote of y equals 0 as x approaches positive infinity. And again, in this case, the limit as x approaches negative infinity, although we don't see what's happening out there. But if that pattern continues and the oscillations keep growing higher and higher, or if it just continues to oscillate at all and doesn't zero in on y equals 0, then would say that the limit as x approaches negative infinity does not exist there. Alright, so that's the second important thing about limits as you go to infinity, as x approaches infinity. And second of all, and third point, a function can have different limits as it approaches positive or negative infinity. Alright, so as in part 3 here, in the third diagram, we have this function as x approaches positive infinity, the limit is positive 1, but as it approaches negative infinity, the limit is negative 1. And so this can happen, and it just illustrates that a function can have different limits as it approaches positive or negative infinity. So we could say that the limit as x approaches infinity of f of x is 1, but the limit as x approaches negative infinity of f of x is negative 1. So this is an illustration of the second type of limit, and don't forget that a limit as x approaches infinity, assuming that limit exists, is the same thing as a horizontal asymptote. So don't forget that particular point there. Alright, so this is the concepts involved with limits, and we'll start talking about some calculations involving limits next.